Hello Year 10, just going to continue with Unit 6, the number subsection in the Year 2 book, which is to do with negative indices. We did fractional indices last week. Now we're moving on to what if the power was a negative number. So, first thing you need to observe is some pattern spotting, which you could do by using your calculator. So if you typed in 2 to the power of negative 1 into a calculator, you would get the answer a half. It's very difficult to know exactly what the pattern is after just one number, but we will continue. 2 to the negative 2, your calculator says it is 1/4. Now some of you might be able to spot of an idea, or maybe this might work, this might be the pattern. A lot of people guess the next answer is 1/6, but it's not. It's 1/8. And 2 to the negative 4, if I give you this answer, you should be able to spot the pattern. It's 1/16. Now, one thing that every single one of these has in common is the numerator is a 1. So it seems to suggest if I get a negative power, somehow the numerator is changed into a 1. Or I get a fraction with a numerator of 1. And if you pay attention to the denominators, then all of the denominators are powers of 2. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4, which is very closely connected to the powers on the left-hand side. And the pattern is that if you've got a number like 2 to the power of minus n, then you have a fraction 1/, and the denominator of the fraction just becomes 2 to the power of n. And this pattern works for every single base, as long as the base is not 0. So a to the power of minus n would be 1/a to the power of n. This is called taking the reciprocal, by the way. The reciprocal is of a number is when you do 1/. So you might see that in some textbooks or in some revision guides, etc. Taking the reciprocal is 1/. Now, the problem is the base doesn't have to be a whole number, it could be a fraction. So let's try and spot the pattern if we extended it to fractional bases. So the first one, if you type that into your calculator would give 3/2. Okay, the next one. If you type that into your calculator, it would give you 9/4. And some of you might be able to guess the next one. If you type that into your calculator, it gives you 27/8. And again, what has happened is, if you look at the fraction itself, 2/3, 2/3, 2/3, then the fractions have flipped, but then the numerator and the denominator have been raised to this power. So this is effectively 3/2 to the power of 1. Whereas this one is flip the fraction, 3/2, but then you square the top and square the bottom. 3 squared is 9, 2 squared is 4. This one, flip the fraction because it's a negative power, 3/2, and then you cube the top and cube the bottom, and so on. So this is, when you see a negative power and you've got a fraction, you flip the fraction, and then you just raise it to the power of n. So you might prefer that as 3 to the power of n over 2 to the power of n. Both of them are equivalent to each other. So the rule that you need to know is negative powers, flip fractions, and then just apply the power to that fraction. Or if you prefer, b to the power of n over a to the power of n. That is a key rule that you need to remember. Now, a few other facts which you might already know, but I'm going to state them just in case, is anything to the power of 0, and your calculator will back me up with this, is 1. Anything to the power of 0 is 1. The reason for that is if you took something like a to the power of n, and you divided it by a to the power of n, then in index form, you would subtract the powers and you'd get a to the power of 0. But there's a rule in maths, very basic rule when you first introduced to division. If you take a number and you divide it by itself, the answer is always 1. So that's why this is equal to 1. Very similar to the ones above, just a specific case. If you got something to the power of -1, you need to be very quick at just writing that as 1 over. 1 over a, or 1 over a to the power of 1, which is still 1 over a. And the last fact you need to know pretty quickly is 1 to the power of something. Now 1 to the power of anything is 1. So those are useful facts that you need to know pretty quickly without the use of a calculator, because they come in handy not just for these numerical bases, but when we do eventually algebraic bases in the next subchapter, you need to know these facts pretty quickly. Right, let's have a look at some of the examples. Okay, let's suppose you're asked to work out the following. Now, again, your calculator can give you the answer immediately. But just like in the internal exam, there was a question about, I think, adding or subtracting or maybe dividing fractions. Maybe you had two mixed numbers and you divided them. Sometimes in an exam, they can give you this as a show that question. So they actually give you the answer and they expect you to explain the maths each step going from the question to the answer. And the explanation can't be, I just typed it into my calculator. So let's have a look at this first one. So 3 to the power of -2. So the first thing you should do when you spot a negative power is attempt to get rid of it. And the negative power is that word reciprocal. And for numbers, whole numbers, it just means 1 over. So there's 1 over 3 squared, because it's to the power of -2. Which is the same as 1 squared over 3 squared, by the way. Which is 1 over 9. And that would be backed up with the calculator. Now, they can give you fractional negative powers, but the concept is exactly the same. That means reciprocal, which is 1 over. But this time to the power of 2/3. Okay, notice the 2/3 doesn't change. 2/3, 2/3. The only thing that changes is this base. The base 8 was flipped to 1 over 8. Now this is the same as 1 over 8 to the power of 2/3 to the power of 2/3. Remember one of those facts. 1 to the power of anything is 1. 8 to the power of 2/3. Can you remember what a fractional power did? The denominator is cube root. Numerator is squared. And then 1 over the cube root of 8 is 2, and 2 squared is 4. It's really important that you don't skip any of these steps. kind of imagining this question as a show that, so you're trying to include every single step. Right. 2/3 to the power of -3. You have to take into account this negative power, which is this word reciprocal, which for fractions means it's going to flip the fraction. So it's 3/2 cubed, okay, which is the same as 3 cubed over 2 cubed. And you should know that 2 cubed is 27, and you should know that, you should know that 3 cubed is 27, and you should know that 2 cubed is 8. And that would be your final answer for that one. Worst case scenario, you get a fraction as the base raised to a negative fractional power. And again, it's really important you get the sequence of steps correct. Got to get rid of the negative power first. So let's flip to the power of 3/4, which is exactly the same as 81 to the power of 3/4 over 16 to the power of 3/4. I really like including that step. Numerator to the power over denominator to the power. Okay, fractional powers, what do they do? Now the denominator is the root and the numerator is the normal power. So this is the 4th root of 81 cubed, and this is the 4th root of 16 cubed. And that would be the perfect workings for this. A number times by itself 4 times gives you 81. That number is 3. And 3 to the power of 3 is 9. 3 to the power of 3 is not 9, it's 27. Over 16, the 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. And then 2 to the power of 3 is 8. 27 over 8. Coincidentally, those previous two, of the last two parts, C and D, were both exactly the same answer. Right, the exam tip I would give you for this is, because the only way you'll be expected to do this in an exam without using a calculator is if it was a show that question. So you're going to treat everything as a show that question where you include all of your steps. Okay, so treat all of these like a show that question, which is the ones where they give you the answer and they just expect you to show the workings. So you need to show your full workings. Okay, use your calculator for individual steps only. What I mean by that, use it for individual steps, is, let's suppose I was going from this second line to this third line. I forgot what this fractional power did, and I kind of hoped it did this. I can just type in 81 to the power of 3/4, which is 27 as expected. Or maybe I don't want to work out what the 4th root is in my head, so I use the root button on the calculator. 4th root of 81, and it tells me it's 3. So use your calculator for individual steps only, not necessarily going from the first line to the final line, because that is pointless. Right, the questions I would be expecting you to do are going to be printed on the class notebook. If you have any questions, let me know.